Alright, so let's solve question number 5. So let's just maximize this. Okay, I'm just gonna slightly bigger. Okay, yeah, alright. So 419, we have to determine any of these guys are water soluble or not. So whether we should probably look for Ca or PO something, PO4. So do I see Ca or the PO4, Ca right here, but I don't really care. PO4, yeah, there you go. There's one right here, PO4 right here. So generally speaking, anything that combined with PO4 is going to be water insoluble, but I don't see the Ca in this list right here, so that has to be water insoluble, right? So that one right here is water insoluble. What about MnOH? I see OH here, I don't see Mn in here, so that means that MnOH is water insoluble, okay? It's going to be solid and solid, right? AgClO3 right here, anything that paired up with ClO3 minus is going to be water soluble, right? No exceptions. So that one right there is going to be AQ. K2S, anything that paired up with K is going to be water soluble, so that means that one right there is going to be AQ. So answer is going to be solid, solid, AQ, and AQ for question number 19. Let's do the question 20 right here. Again, the same stuff. So do I have the CO3 or the Ca? Oh, the CO3 right here, right? So anything that paired up with the CO3 is going to be water insoluble. I don't see the Ca listed here, so that one right there is going to be solid. Zinc SO4 is going to be water soluble, exception right here. I don't see the zinc here, so zinc Zn, right? So that one right there is going to be water soluble. HgNO3, anything that paired up with NO3 is going to be water soluble, so that's going to be AQ. HgSO4, I know that SO4 was somewhere around here, so it's generally speaking it is water soluble, but when they paired up with Hg, which in this case it's listed as exceptions, so that one is going to be water insoluble, so that one here is going to be solid. NH4ClO4, do I see the ClO4? NH4, yeah, NH4, I see NH4, anything is going to be water soluble, so that's going to be AQ. Alright, then let's do the question number 421, part A. So we are supposed to write out the equation for net and just ionic equations, right? So AgNO3 AQ plus Na2SO4. Alright, so let's just switch the screen here. So we have this one, right? So Ag was originally paired with NO3, right? So what we are going to do is that any positive is going to be always paired up with negative. So that one right there, not this one, but that one, because it's already paired, right? And inside pair, it's going to pair up. Now there is a little bit more to this one. because SO4 is going to be 2 minus, right? But Ag is going to be positive, right? NO3 is going to be negative. How do I know this thing is just singly charged? Negatively charged? Singly negative? Because I know that Ag is positive, right? Na, each one of those is going to be positive, right? So it looks like that when I try to pair Ag with SO4, I need to have 2 of these, right? And then NO3 paired up with 2 of Na, then I need to have 2 of those, right? So basically I have to multiply by 2 first. Then what is that the ionic equation look like? 2Ag plus 2 NO3 minus plus Na 2Na plus SO4 2 minus. It's becoming, just gonna move this one. So Ag is gonna pair up with SO4, right? AgSO4, but do I actually have the AgSO4 being solid or liquid? Solid or the AQ? AgSO4, by looking at these guys right here, I know it's gonna be solid, right? So Ag2SO4, that's solid, plus anything that combined with Na is going to be water soluble, right? So 2Na plus 2 NO3 minus. So that will be right here. That's our ionic equation. And then what is the net ionic equation right here? You just need to cancel out some stuff, right? So you get this one, right? Then net ionic equations, I can cancel NO4, NO3, right? That one and that one, and then Na and Na, right? So if I cancel that one and that one, that one and that one, then I get 2Ag plus SO4 2 minus is becoming Ag2SO4 solid. That will be our net ionic equations. Right here. These are ionic equations. You write out everything, do not cancel. Net ionic equations, you cancel everything, right? Generally speaking, the net ionic equations end up in one side becoming solid, and then the other side becoming the ions. And the other stuff that I really want to mention is that they swap pairs here, right? So Ag paired up with NO3, right? The positive side and negative side, positive side and negative side. Positive side swaps the pairs with another negative, and then this positive is going to swap pairs, negative pairs, with that guy, right? So Na plus used to pair up with SO4 has to pair up with NO3. Ag used to pair up with NO3, change the pairs, and then form AgSO4, okay? And then you just balance the charges. That will make 2 here, right? Because SO4 2 minus, Ag plus. All of these things end up in the neutral, right? That means that the charge 2 negative and positive, I have to have another positive to make a neutral here. So the total charge is kind of important. for example, like this one too. Na plus and Na plus, total of 2 plus, right? SO4 2 minus. So 2 plus and 2 minus is going to be neutral, right? So you should be careful about every pairs with if the charge is balanced or not, or to give the correct net charges, and then see what happens with your stuff. So let's go back to the screen again. Alright, let's do another problems, right? What should I do? Maybe B for this one right here. So write out the net equation for the following reactions. So let's just do the 22B right here. So K3PO4AQ plus 3SrNO32 to form what? That's the question, right? So let's go back to the off screen. So now I have these equations, right? So remember that K in the periodic table, right? Periodic table look like this. K is here, right? So positive 1, positive 2, and that's your noble gas. That one is a column for negative 1, and that one is for the column negative 2. So some stuff that you might want to remember. So the very first column is going to be positive 1. The next up, beryllium and the calcium and so on and so forth. All of those guys is going to tend to have the 2 plus, and then the noble gas is going to have 0, and then that fluorine, chlorine, so on and so forth is going to have negative 1. Oxygen, sulfur, all of those stuff is going to have negative 2. So that's just a general rule. So SR happened to be somewhere around here. So I know that this one right here is going to be 2 positive. NO3, what do you think about this charge right here? If the whole thing right here have 0 charge, right? So if you have 2 plus on one side, you have to have 2 negative on this side, right? But 2 negative by adding 2 units of this guy, right? So each one of these guys is going to be negatively charged, just single negative, right? And then for the K plus, remember that K plus was here, right? So the K, each one of these is plus, and then you have 3 of those, right? And then whole thing is going to be neutral. That means that this one right here is likely to have 3 negative, right? So the net ionic equations, 3K plus PO43 minus plus SR2 plus, do I have? Yeah, sorry, 3SR plus 3NO3 minus, but you used to have this one, right? So how many NO3 do you think I have? You have unit of 2, you have 3 unit of 2, right? So 3 times 2, it's going to be 6. 6 of that. And then you swap the partners with these things. So right here, K is going to pair up with this guy, But take a look. I don't have enough of this, right? I have 6NO minus, but I have only 3 plus here. What do I need to do? Yep, I have to multiply everything by 2 on this side, right? So that one is going to be 6, that one is going to be 2. So that is going to be 6k plus 6NO3 minus plus 3SR2 plus 2PO4 3 minus. Awesome. So that's our ionic equations. Or is it? Not really, right? I still have to figure out that if this things or that things is gonna be solid or not, right? So let's just check. K is gonna pair up with anything, and all of those things is gonna be AQ, right? So that's gonna stay as is. But what happens if you actually pair up SR and PO4 3 minus? So if you actually look to your own table, or maybe that I'm gonna switch the screen here. What I'm looking for is the PO4 3 minus. Generally speaking, it's gonna be water insoluble. Exception is this one, but strontium is not included here. So that one, right? Strontium PO4 pair is gonna be solid, water insoluble, right? So I have to change a little bit around here. So instead of this, I actually have SR3 PO4 2, right? Because SR3 PO4 2, that is actually solid, which means it's water insoluble. So that one right there is ionic equations. What about the net ionic equations? Net ionic equations, cancel that, cancel this, cancel that, cancel that. Then you get 3SR2 plus 2PO4 3 minus is becoming SR3 PO4 2. That is solid. So that one right there is a net ionic equation. And I think you can do the rest of the problem. So please work on that one by yourself. So that concludes this example. So if you have any questions, let me know, and I'll be available.